Hi guys, welcome to a video demonstration regarding the blueprints of my twin stick shooter game. And let's just set it up first. And I'm opening Unreal Engine right now, opening my final twin stick Unreal Engine project. Alright, so as you can see, it's now fully loaded, and now it has like a fade effect to it. That's because the tiles have like an emitting color. So yeah, that's why it's fading in from black to white. And I don't have any light actually in this place, just the directional light, which serves like as a, like it just serves as the theme color for the platforms. It makes the platform look violet or purple, but it's actually just gray. It's just the light that's making it purple. And plus, I've lowered the saturation so that the neon color doesn't really, like, if I take it out, it's going to be neon red. Like if you look at it, it's going to be neon red like that. And I pretty much like this actually, but I just really want the flavor to it, like make the color more vibrant. Like, look at this nice purple, and it matches the portals as well, as you can see. And the portals have like a glowing effect to it as well. And it's just actually like a water mesh inside of this mesh, because it's a mesh in a mesh. I made the portal mesh itself, but anyway, so it's basically like a water effect, so it looks like something's going on in there, like a foggy type of portal, and then it's glowing and has like a light rectangle shadow, which is caused by the rectangle light that I have applied to it. So there's two rectangle lights, that one is like lighting up the mesh, and the other one is pointing out to the world over here, so it's pointing to the other direction. So it's just basically like making this kind of portal light or shadow to it. So yeah, so that's basically it. And for the graphic design of the map, I based it off of the arcade 80s type of games, where it's just like a square map, and it looks actually like a game that I used to play, where you're just supposed to like place bombs. I don't know what it's called anymore. It's a very old game, and my grandfather used to have it. And they would casually hide it because I would get addicted to it. Anyway, so it's a tribute to that. And the map is actually kind of designed from circuit boards, so the inspiration came from circuit boards. And each design is actually made by a small tiny static mesh made from a hex tile over here. So it's, yeah, I spent like way too much time on designing this map, but it was worth it. It looks so retro, and it looks like it's pixelated or whatever, and it works really fine, and I really like it. Also, now that we have discussed the map, let's discuss some of the mechanics of the game, its blueprints, and other stuff. So first of all, I have separated the starter content and the twin stick shooter content here in our content folder. And then this is the base character of our game. I basically just followed what the instructor has said, and added the health and the is dead variable, calculate dead function. Um, this will help us calculate and check the health of the character and check if they're dead and all. So it will, this is really viable for us. So this base character, um, we actually have two characters in the game, and they're based off of our base character. That's why it's called base character, by the way. Anyway, so there's two characters. One is the hero character. Okay, I'm having a hard time. Oh, never mind. This is the actual folder. So we have two characters, the enemy character and the hero character. So let's check out the hero character first. So this is our hero character. He's just holding the gun, and in his holding gun position, I think it's in the animation it's called idle rifle hip. So yeah, it's just this one, and we have a spring arm that serves like a selfie stick that is attached to the camera, which is over here. And this is our like camera for the game. Yay! So this is how it looks like in game. Yeah, so that's that. It's attached to the spring arm. Now we look at the blueprints. So this is my weapon setup. So basically when the game starts, these three conditions are like set into function. So one is to set up the HUD, and the other one is set up to the weapon, and the other one is to set where is the initial spawn point. So actually I do have like a player start, but yep, I do like a player start, and if we die, we're just gonna spawn to where we last spawned at, if I'm correct. I'm not really sure. Let's try and see. Let's try if we play this game right now. Yep. And then if we die, we're just gonna spawn. Okay, that's pretty neat, but I really like the initial spawn here, over here. So this is the player start, or the initial spawn. Anyway, so it sets the initial spawn of the character. It checks this one. It gets from the game mode, which is our twin stick mode, and then once it gets that, it takes the character's spawn location, and it's just every time the hero character is spawned, it will set the value of its location to the player spawn. And then this one sets up the spawn of the weapon as well, so that once the game is loaded, the weapon is in the hero character's hands. As you can see, there's no weapon here, so the weapon is just a mesh, and in order to have that appear on the screen, we have to call it and attach it to our hero character. We've attached it to the gun socket, and if you can remember, the gun socket is actually a part of the skeletal mesh for this character. I'll show it later when we reach animations. Anyway, this is the mesh for the weapon, and then it's basically just showing the weapon. Anyway, the HUD is actually the different elements you see in game, such as the health, the score, and the other texts you see on screen during your playtime. So that's just the HUD. So when the game loads, or the game begins, it just loads up the HUD, and this HUD is particular is the twin stick shooter HUD. Okay, for the rotational movement, this is the blueprints. First, we get the there's two actual movements. Actually, we should probably take those together. Oh, sorry. What did we do? What did we do? Oh no. We should. Sorry, I kind of ruined my thing. Sorry about that for the delay. Anyway, we just set this to up. Perfect. Anyway, we'll just have to move it near the rotational movement so it's not very confusing. So yeah. So this is the directional movement and this is the rotational movement. So the directional movement is responsible for the character's movement, which is the left hand stick. So it takes the move up and the move right. Yep, it's the move up and the move right. And if you can remember, we've set the values of the axis already at the start of the project. So this just defines what direction move up is. So over here it's our x is 1 and over here our x is y. So this is our x axis, this is for our y axis, if I'm correct. Yes. I think we've inverted this actually, but yeah. And for this one is our rotational movement, responsible for the right hand stick and our shooter as well. So first it gets the direction, turns it into a vector, and the vector gets the length and magnitude, because vectors are basically I forgot what they are called, but they basically have length and magnitude. So it gets the vector's length and then compares it. If it's greater than the extent of the joystick, we've set the value to 0.25. And then once it gets that, it checks if it is greater than the full extent of the joystick. And if it's true, it sets the control rotation, which is where the character is facing, and then this just gets the which controller is driving the pawns. And for this particular hero character, it's us. I think it's a third person maybe, or the player. I forgot. We have to check it later. Anyway, so also if it turns out true, it takes the x-axis and returns a value, so it gets the rotation for that. So once we get that, if it's like greater than the full extent of the joystick, it then checks where it's facing, and then it triggers this event called pull trigger. And pull trigger is responsible for the shooting of our laser weapon. And if it's not in the full extent of the joystick, it just calls release trigger, which means that we're not going to shoot anything. Yeah. So yeah. Okay, so for this one, the character status and it's actually the character status. Both of these are just connected to each other. I just made like division, because this one is just checks if the character is dead. Like so affect health, which is from our BPI damageable. It's like a blueprint instance which is named damageable. It then checks if the calculate health, through calculate health function through the base character, it checks if the character is dead. So if its health reaches 0, which will be included in the boolean variable is dead. So if the character is dead, if it turns out to be true, or the health here from calculate health reaches 0, it means that the player is dead. And if it's true, it disables input. So if the character dies, it's just gonna play the animation, and we are not able to move anymore. Because if we remove it, the character will still move, even though they're dead. At the same, like they're falling down and they can still move. You know, it's pretty weird. And after we've disabled the input, it will release trigger, so that the weapon will not fire even if the character is dead. And after that, we've set a delay, a 2-second delay, just so the animation could play it out around 1 second, and then another second for, like, you know, it's just like a right time to respawn after 2 seconds. And after that, we respawn the player, so it spawns a copy of the hero character, and then it possesses it, and then it's called a red from the game mode. And then once the characters respawn, it will destroy the previous hero character, and yeah, it will also destroy the weapon. So there's two types of variables that it will destroy, which is self. We've called a reference to self, and reference to our weapon. So yeah, that's for the hero blueprint. And then for the enemy character, it's just 2. This is to apply damage to the hero character, and this one is to take damage from the projectile. So this one is to apply damage. So we'll discuss this first. So this small part, it helps to take the damage count and cause effect health to apply damage. So this custom event calls the effect health function, and then its target is the hero, and the delta is the amount or the value of the damage, and the value is -20, because if you've noticed in our Visual Studio Code, to implement damage, it must be negative, because the where is it, the health is 100. So if we wrote delta 20, it would just add health. So we need to decrease health, which is a 20. We could set it to a different value, but 20 is actually good since it's just a prototype anyway. Next, so since we have something that calls the effect health function to apply damage, we now proceed on the other event, which is the actor begin overlap, which means that once the enemy character is overlapping something, and that something is the hero character, because we cast it onto it. So now it's casted to the hero character, and we have promoted it to a variable, which is the hero. And now we set a timer, which is we set a timer by function, which is the damage hero character, this event here. So it calls this event, and then we turned on looping, so that it keeps on looping. Once the enemy touches the player, it just loops, but there's a time, so it will refresh. And So it's actually damage per sec. Can't, instead of damage cap, let's change it to that. Alright, if we compile this one, so as you can see, the damage per second is 2.0. So the time is there will be like 20 damage per 2 seconds. Yep. Ta-da! Anyway, so next is the actor end overlap. So once it stops overlapping, and so it's if it's still overlapping the character. Wait, let's turn that on. And it checks if it's equal, so this event is equal to the hero character, and if it is true, it will then clear the timer, which is this one that sets the damage per second. So it stops inflicting damage once it ends overlapping. Okay, so next, this is just the instance blueprint, and it's just calling the effect health function in our code. This one is the AI, and there's two particular things here, which is one, what it reminds the AI to keep tracking the player, and the other one is the track player event. So the track player event tells the AI to move towards the target actor, tells AI pawn to move towards the target actor. Perfect, we've changed that. And then so it's referencing to get the controlled pawn, which is our enemy character, if I'm correct, and then the target is the player character. So this enemy character, which is the pawn, is the AI will be telling this one, the pawn, to move to the target actor, which is the hero character. And then this one is just basically like to keep telling the enemy character, like, hey, you need to move towards this player. So once the game starts, they will continue and will always move towards, or will always be calling this function. They will always move toward the player. So that's just that. And we now move to the game mode. So the game mode, we have particularly three things here. One is the spawn enemies at the start of the game. So this is the enemy spawner. So once the game begins, it gets all the actors of class that it can find, and then so the actor in this particular event is the enemy spawner, if I'm correct. Enemy spawn point, sorry. So it's the enemy spawn point. So it gets the enemy spawn point, and it's like, it shows like an array, and it gets the array of like enemies, and then we've set it to a value of the enemy spawner over here, and we've set a timer by function again to call spawn the event spawn enemy over here, and then it loops, so it's always going to spawn enemies, and the time will be 2 enemies for, one enemy per 2 seconds. So if I'm correct, this is actually like getting the max number of enemies, if I'm correct, because the enemy spawn point has like a blueprint which has like all the enemies that it can produce. So it takes that and gets it into an array, and then now it will just keep on spawning that. the enemies. Yeah, that's basically how it works. Anyway, so this is the spawn character in game. It lets our character spawn. So respawn, sorry. Respawn. Oh, sorry about that. Sorry. Anyway, so this particular event, the respawn player. So first it destroys. Oh, there's a typo. It destroys all enemies in the game. So once you wait, let's see if it's still recording. I'm scared. Okay, it's recording. So once the enemies in the game, I am sorry about that. Once the character has been destroyed, and I mean, once the character has been respawned, it will destroy all enemies, and it will then have a for loop, which um, which will just basically execute until all the enemies are destroyed, you know. And then once completed, it will spawn the hero character. And then so this is the player spawn variable. If you remember, we have already set a value to that in the hero character blueprint. And once it spawns the hero character, we then possess it, instead of, because if we don't, it's just gonna respawn, but we won't have any character to control. So we possess the hero character that's just been spawned, and it sets the target to player index 0, which is just for like single players. We can change that if we want to do it like a multiplayer game. Anyway, this particular one is to increment score, so it's used for the HUD. So it takes the existing score and increment value to it. So the existing score is 0. The delta score is 0, if I'm correct. Yep, it's 0. And then delta score is a different one, so it adds to the score. So every time we've killed an enemy, it will add to the score, and then once it's added, it will set the value to the score. I don't know if it makes sense. I explain really weirdly, but yeah. And next we go to the weapons. This is the blueprint projectile. So its purpose is to apply damage. So this will trigger once it overlaps with something, and then it checks if the blueprint is implemented. So if it is implemented, it will check if our enemy has the friendly tag. So the only person that has the friendly tag is the player. So if it hits the enemy, which is not a friendly, which it has no friendly tag, the pawn has friendly tag. Sorry, that's a mistake on my part. So if it has a friendly tag, it's true, it will then checks if pawn has checks if pawn has friendly tag. Okay, if it's true, it affects the health and decrements value to health. Then it will take damage, and then it will proceed to here, which we will discuss later. Now the next part is if actor has tag. So if the actor if the actor has not a tag, so it will check if the actor has tag, the one that it overlaps with. So it will do nothing if it's if it's if it's if the the projectile hits something with the friendly tag. It does nothing. We don't have a false execution. But if it does not have the friendly tag, checks if the pawn does not have a friendly. Perfect. So if it has the friendly tag, it does nothing. But if it does not have it, it will proceed to decrement the health. What else? So this one is just referencing to the actor being overlap. And now we move on to what happens next. So if the 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 thing that overlaps the projectile is something that is been implementing by the blueprint instance damageable. If it's not, it will also move on to destroy the particle. So it will just do nothing basically. So if it hits nothing, or if it hits something that's not both of this part, it will just destroy itself. And after it hits an enemy, it will just destroy itself. But before that, if it does hit an enemy, it will spawn emitter at location, which is just a particle system that we've made at the last part of the tutorial. And then this is just after the emitter or the projectile has been the projectile particle system has been implemented. It will then implement the gunshot sound that you hear, like the or something. Then it will destroy the particle. I'm doing my best to explain everything. Sorry if it's kind of convoluted. Okay, next it's the blueprint weapon. So for the weapon, we have 3 events. One is the fire custom event, and one is the pull trigger, and the other one is release trigger. You must be familiar with the pull and release trigger. Pull trigger is triggered when the controller like the controller is on something. The right stick has been pulled, and if it's not, it's just released. So first of all, let's discuss first the fire projectile event, which basically it says fire, so it's just firing the projectile. So once it has been triggered, it will spawn the sound of the laser, and then it will spawn the projectile. Oh, sorry about that. It will spawn the projectile and get the projectile spawn point, and it will start from the projectile spawn point and into the world, So that's that. So that's fire. Let's just move it a little bit here. Perfect. Okay, and for these 2 events, so pull trigger, it only does it once. So once the trigger has been pulled, it will call the fire custom event, and it will set a timer, and it's also in a loop, so it's not going to stop unless you release the trigger. And the bullet rate for this one is 7 bullets per second. So yep. Next is the release trigger. So if the controller, the right hand stick has not been pulled, it will trigger the release trigger event, which clears the timer, which is will not call fire. So it will not do anything once it's released. Okay, so that's that. Next, the material projectile. So we just basically multiplied the parameter of the base color and added a glow intensity to it and set it into like a emissive color so that this material will appear to glow. Oh, would you like to apply? No. Next is the laser spark. So this is the particle system that emits once the projectile has hit the enemy, and it's basically us changing the color and the I guess this the um, I think it's the radius as well that we've changed here. There's not that much changes. We just changed the color, the rotation, and the radius for this one in particular. Yep. Anyway, we move on to the widget. This is the HUD, and we've just basically have two blueprints for this one, which is the health bar and the score. So for the health bar, we've cast it to the hero character. So we get the player character, we cast onto it and promote it to a variable. And we take, no, never mind, we don't promote it to a variable. We just take the health of this character, this health variable. So, and then if it gives out the value, right? Since the character's health is 100 by default, we've set the maximum for the health by 100, and then it will return the value because we're basically dividing it by 100. So 75 divided by 100, it will return that value, and it will show graphically here in our bar. And next, we've also done this same thing similarly to the score. We've cast it onto the game mode, so we get the game mode. And then we, from the game mode, we take the value of score and then converted it into two text from integer. So it's, since it's an integer, we need to print out a value in text. So we've set this one to change the format, and we've returned the value. So it will return the value here in our HUD graphically as a number, but it's not actually a number, it's actually a text. It's a text number. Well, sorry. Okay, so we've discussed the map. We haven't discussed the enemy spawn point and the portal. Okay, let's just open up things. So the rest are just meshes that are pre-made. These are the audio. I'm gonna open the audio queue for that. I've already discussed this, and then animation. Okay, I'm just opening it up so that later we don't have to go back here in our content browser and just discuss them. Okay, so the enemy spawn point. So the enemy spawn point basically is the place where the enemies will spawn. So dumb of me. Of course it is. Anyway, it's just for the name, you know. So it first gets all the actors of class, which is the enemy character, takes its length and compares its value to the maximum number of enemies. So we've set the maximum number of enemies to 10. So it gets the length. So for example, at the start of the game it's 0, but since that we're going to spawn at least 2 enemies at the start of the game, it gets 2. And if it's less than since we've just spawned 2 enemies and the max number is 10, and it will go as true. So the spawn enemies are the max number of enemies are not yet met, so it will then call the spawn AI from class. So it will spawn enemies up until it reaches the maximum number of enemies. This will only work if the enemies are not yet in the value of 10. Oh, we've changed it. I'm so sorry. It needs to be 10. Because it's too hard if you'll make it 15. Anyway, so now we're gonna let the spawn AI from class know where to spawn the enemies. So we get a random point in the bounding box, which is our, this is the bounding box, which is it gets the world location and the scaled box extent. So this is the scaled box extent, or actually this is the scaled box extent because we've extended it, and it gets its world location. We've promoted, I mean, the variable spawn volume is where we've spawned the enemy, if I'm correct. Yep, this is where the enemy will spawn, and it just gets the world location, and it allows us to scale the box where the enemies will spawn, and then whatever point inside the box, it will spawn the enemy there. Okay, next is the portal. So this one's kind of complicated, but first let me just drink some water. Alright, so first of all, event hit. So once an actor has bumped into it, specifically our hero character, we've specified it to be the hero character so that the enemy characters would not teleport to once they hit the portal, because that would suck. Anyway, so once you've hit the teleporter, the portal, it will play a sound, which is the teleport sound, and it will check if the player has entered a front portal. Think of it as an entrance. So is it an entrance? Is it a front portal? It's the same thing. I just call it front. Anyway, so it checks. I'll just call it entrance for now. So it checks if it's the entrance. So if it is an entrance, it then gets all actors of class, which takes all the blueprint portals in the map, and for each of them, it will check if the portal has the same reference number and if the index is linked. So there should be 4 portals in our map, and 2 of them are linked together. So if we enter this one, let's see its index. So as you can see, it's a front portal. It's an entrance, and the index is 0. If we look at this one, it's not an entrance, but it has the same index. So basically, they're interconnected. Think of it as like this is the door you enter, and then, for example, this is your room. Okay, this is your room here, and you want to exit your room, so you exit your room through here. Now you want to go back to your room, you just turn around, right? Instead of that kind of mechanic, the back of the door is this one and the front of the door is this one. That's why I call it front. It's complicated. Anyway, so it just checks if it's the front. So if it's the front and it's linked, are they linked? Yes, they are linked because they're both with a portal index of 0, if I'm correct. Yep, they have both portal indexes linked together. So if it is, it's completed. This loop stops. That's how loop works. So it stops, and then it implements set actor location. So it will spawn the player at the door. For example, if you entered the front, you will exit at the back, and if you enter the back, you will exit at the front. So for this to happen, we will set the actor location to, we will get it from the world and set it to the set exit reference. So exit reference is actually where the character will spawn. So if it hits this one, if it hits the portal, it will spawn to this box. And it's hidden in the game, so don't worry about it. It's non-collidable. It has no collision. It just determines where location should the character spawn. Anyway, so this part over here, it's a condition for this one as well. So it targets off of the array element, which is the portal index. So the target portal, it compares the portal indexes of each doors. So for example, you've entered the front and it has a portal of 0. So it takes that and it checks every door. So for example, it sees the portal index is 1, it will set the condition to false. So we don't have any false, so it just keeps going up until this comes true, and once it's true, that's okay. Now it checks the array element, which is the front. If it's not a front, and if it's, oh my god, what's happening? My entire screen is black. Am I still recording? Oh my god, it crashed. Did you guys see that? It just crashed. I wanna cry. I was demonstrating my game. This always happens with Unreal. Oh my god. If this happens to have like an error or something, I'm gonna cry. I don't think so though. Anyway, we go back to it, this one. So if it is not a front, if it's not a front and it's true, and this one is true, they are linked, and it's not a front portal. So this is a front portal. It's not a front portal. If they're both true, it will finally break the loop. Okay, and then it will spawn the actor or the hero character to this location, the exit reference. But if the character has entered a non-front door, it's basically the same. It gets all the portals and checks every references if it's linked, and then for this one in particular, it compares if the door which doors are linked together. So if it's true, this will print out true, and then for this one, it checks if the front, if it's not a front, and this one also checks the front. So it's an AND. So it means like if these two values are true, then it will be true. So if it's not a front portal, if this is not a front portal and this is the front portal, it should be false. Yep, it should be false. And it will only come true if it detects a portal that is a front door and that has the same index as the back door. And then it will break the loop, and then it will also spawn the hero character to its exit reference. I hope it makes sense. But it makes sense to me. Sorry. Anyway, okay, we've got a little bit sidetracked because my computer just black screened and OBS was not working properly. Alright, so let's go back and let's see. I think we're the only things missing is just the blended animations, because everything else is a-okay. We should check the animation blueprint as well. So this is the animation blueprint. It's just basically making a blend space. This is just the blend space for the character. You know, we didn't really do anything much with here. And then same goes with the enemy. Yeah, this is the hero one. This is the enemy. And the enemy blend thing. Here you go. This is it. It's just the blend animation blend space. This is the blueprint for the event graph of our animations. This is what we call a state machine, and a state machine contains all the different animation states. And for example, we can create like a state where when the character is swimming, we can make a state when the character is flying or levitating and stuff like that. So we just differentiate them into different kinds. And for this particular game, we just have a locomotion and the death. Locomotion is for movement, death is for death. So for death, we have 3 different animations, and death anim select is just a value that is selected by our blueprint. So it's since we have 3 animations from 0 to 2, 0 to 2, but it's 1, 2, 3, but it's 0 to 2. So it selects if the random generated number is 0, it will choose this animation. If it's 1, it will choose this one. If it's 2, it will choose this one. So that's basically it. And for the locomotion, it's just basically taking the direction and the speed of the character, whichever part of they are in the screen. So if they are moving towards the left, and they have a speed of this, like if they're moving at 400 speed, it will then transfer over to this, the hero blend space, because we need the direction this and the speed for the animations to work, and it will then result to the animation. So for this particular event graph, we have an event appropriate update animation, which executes when the animation is updated. So it checks if the animation execution is valid. So it checks, it gets the pawn owner. This case it's the hero, and then it then gets the velocity and takes the magnitude of the vector. So magnitude is a velocity is a vector, and then there's 2, we need to get 2, which is the vector length and the rotation from x vector. So once we get the vector length, that would be our speed. And then once because you know the speed is controlled by, I think it's the movement pads, if I'm correct. It's the left hand stick, and the direction is the rotational movement, so it gets them the x vector, if I'm correct. Yeah, it takes the yaw, because it's basically if we where's the, yeah, The yaw is actually this one, the y-axis, the y. So this one is the z. Z is upwards, x is this way, and yaw is this way, the front. Then it takes that one and it sets it as the direction because the yaw is to the front. And it also we also then cast it to the base character. We check if the character is dead, and if the character is dead, which is true, it does this once, which means that it does the animation once. I mean, it does the death anim select once, so it generates a random number once they're dead, and it only does it once. So it generates one number and sets it to the death anim select, and then it transfers it over to our death sequence generator, and then it will play out whichever is the number that has been chosen. And same goes with the enemy. Let's see, I think the enemy is just like a child class of the state machine. Yep, it's just basically the same, and it's based up of the hero animation blueprint. We just changed it to the locomotion to the enemy blend space. That's why it has a different animation. But it's basically the same code, you know. I mean, the blueprint is the same, it's just different animation. Okay, this is the mannequin. We didn't actually code anything here, I think. Yep, we didn't. Okay, what else did we miss? I think that's basically it. Yep, this is just the fonts and everything. Yep, we've finally finished. I hope you understand what I've said because it's really convoluted. I'm really sorry, but thank you for watching, and I hope I was able to get across what I was explaining, as well as I hope you enjoy my game if you've already played it. It's basically just a simple twin stick shooter game inspired by one of my favorite genres, and I hope more games from this genre to like get a lot of attention, because most of us are like enjoying the futuristic genre games, adventure games, like board games and stuff like that. We're not actually enjoying arcade games anymore as much as we do before. It's quite sad, but I don't know. I hope you guys enjoy it and have a wonderful day.